So this is a joint work with Ian, Asant, and Sonia. This is going from unstructured text to causal knowledge graphs, a transformer-based approach. Okay, so cognitive systems have to reason about causality across different domains to be effective analytics or to be effective collaborators. In this work, we are going from text to causal models, or causal structure rather. We're not doing full models. This is not a cognitive model in itself. It's not cognitively plausible NLP. Rather, what's interesting here for cognitive systems is the output. Our system outputs qualitative causal structure that's usable by cognitive systems. So our claims specifically are that qualitative causal relations and the reified events from our system can capture domain general monotonic, intentional, temporal, and functional causality. So it's the diversity we're interested in here. The transformer-based NLP can extract these causal structures from text with acceptable F1 score, but it does have weaker semantics than some symbolic systems that, say, use ontological types as selectional restrictions, much of which is by people in the audience here and also cited in our work. I show some results in two different domains, one in scientific claims and understanding the causality within those, and then in ethnographic modeling, looking at different cultures and the intentions and values of those. This is a 10-minute talk, so I'm going to show you a lot of pretty pictures, hopefully not give you a seizure here with the speed that I'm going. All right, so in scientific journals, we would expect sometimes to see really crisp causality and complete knowledge. Those of you that have done NLP on scientific journals know that's not quite the case though. For example, guidelines developed by experts may improve the treatment of COVID-19. There's hedging here. You're not always sure whether something's increasing or decreasing if you're trying to do qualitative reasoning, but treatment tells us probably it's decreasing some type of disease if we know the context. Levels of social support for medical staff were significantly associated with self-efficacy and sleep quality and negatively with degree of anxiety and stress. Well, this isn't causal at all. This is a correlative relation. We're not clear always whether that correlation is increasing or decreasing, but sometimes they give us a nice hint there. Most importantly, there was a significant certainty by objective ambivalence interaction. And with things like this, they hedge on the directionality of causality as well as the sign of change. So all we can do here is represent the statistical association. With ethnographies, it gets even more diverse. It's consoling that somebody's praying for you. This is a positive event relatedness between the prayer and the consolation. In other circumstances, pastors were consulted when women could not feel fetal movements. And when, in this case, could be temporal precedence, or it could be a logical conditional, not necessarily clear. At 7 months, I could not feel my baby move, so I went to the hospital. And the so could be rationale or just temporal precedence, but Gricean principles would say that it's probably rationale. Hawa had gone to a health facility to deliver. In this case, this is probably related by agent intention. You have a goal, so you have a task to get there. So all this diverse causality, we have to reach pretty broadly across the literature to find the right representations. First, an obvious choice is qualitative proportionalities. This tells us that one thing increases when another thing increases. So we have a direction of causality and the direction of change. This is the simplest monotonic directional representation we can reach for. So smoking increases ACE2 expression. The intentions of agents and goals we represent with an intent plus. So I sang to comfort him. In this case, we have an action taken to achieve a downstream action. A function plus relation to represent teleology or function within the cognitive psychology literature and also in the linguistics literature. So a spatula is for flipping pancakes. And temporal precedence is kind of a fallback because this expresses temporal ordering. It could actually indicate causality, norms, plans, and Schenkian-like scripts if we're describing what we did after the last thing, but we don't always know. So we have to look for the simplest linguistic move and represent that. So this is a temporal precedence. So that's broadly the relations we are going to extract with transformer-based NLP. To do that, we use a web-based UI to annotate these things. Because we're not programming in rules, we are annotating examples with these rich relational causal structure. And then we have SPEAR. This is our transformer-based NLP architecture for extracting knowledge graphs from text. So we developed this on top of other architectures too. I'm not going to get too deep into this, but I'm happy to do so in the breakout session. We encode everything. It does an entity-based classification. It then classifies relations on top of those entities that it finds. And then it does attribute-based classification using multi-class categorization on top of all the nodes. So the result is a directed, labeled, multi-directed graph. As an example, consider this text from the ethnographies. The women prayed to prevent any complications. The first step is to find the entities or the nodes in the graph. So here we have women, prayed, prevent, and complications. The other ones are ignored by the transformer-based model because of the training data that was supplied. These become the nodes in the knowledge graph. So the attributes are multi-class types expressed on these nodes. So actor and female goes to women, influence goes on prevent, and so forth. And the relations are labeled directed edges across the nodes. Now we have many representational constraints here. Unlike symbolic NLP, that can do arbitrary inference, follow-on inference here, we are limited by the nodes and entities that are directly inferred with token support. So it can't be a node if it doesn't come from a token or span of tokens within the text. Of course, you could do additional inference with the inference engine, but that's outside the scope of our present system. This is also a directed multigraph because you can have multiple edges between different nodes with different labels. After that, our system uses the language modeling makes sense package to encode a vector for each token within a node. So prayed is a token, for example, and it dot products each encoded vector from a token against WordNet sense keys, which also have vectors. This allows us to compute the top k sense keys above a certain threshold, such as 0.5, which we use here. So here's the top 5 sense keys for this, in context, the word prayed, which is a node within our graph. And this maps each node's tokens into the WordNet ontology, potentially to multiple locales in the ontology. This is all connected by the meronym and hypernym trees and so forth. Instead of thinking of the top, the most confident word sense as the one true sense, we really consider this a distributed locale over the entire WordNet synsets. Unfortunately, this also triggers unusual word senses. So today I learned that Maenad is actually a female follower of Bacchus, which is definitely not relevant here. So WordNet has some really odd corners, and we think we can subdue some of these by doing frequency-based weighting over these word senses as well, but that's future work. All right, so in the first domain of scientific claims, we use 900 sentences from these diverse sources, mostly social behavioral science literature and PubMed. And here, you can read the paper for deeper analyses, but these are the results. We have pretty acceptable entity-based F1 scores, attribute F1 score, and relation F1 score. The relation F1 is the lowest because we require correct entities to be extracted for the relation to be correct. So we don't award partial credit for this. But still, we're extracting these causal relationships and such with adequate F1 measure. So this is evidence that a transformer-based system can pull these causal structures from context. In a second domain of ethnographic analysis, we have over 700 sentences from ethnographies, interviews, folk tales, and social media. Instead of showing you more tables, I'll show you what the system can do with the outputs of our transformer-based model. So the prayers were aimed at averting negative consequences on the pregnancy. This is the parse for that. It has intentional causality as well as qualitative proportionalities. So here we have no actor on the prayers because we don't know who's praying, but we know that the intent is to avert negative consequences. We can then do graph propagation to figure out what the value of this speaker is. So in this case, there's some intent to avert negative consequences. So that's positive valence to do this, to achieve this goal that is stated as a goal. Then we have Q minus, which flips the valence to negative. So negative consequences on pregnancy is negative valence. And therefore pregnancy is, broadly speaking, high valence in this prescribed context. So a much more complex example is right here. He saw in a vision that the witches had planned to terminate my pregnancy, so the pastor prayed to prevent it. Here we do have actors, and so we can actually propagate their own intention and their values over this entire parse using the causal structure extracted by the transformer system. For the witches, where are they? Here they are. The witches' plan is high valence because they're doing it. Their intention is to terminate in the plan, so they intend to terminate, that's high valence. And my pregnancy is low valence to the witches. For the pastor, he is kind of the opposite here. Praying to prevent the witch's plan is high valence, the witch's plan is low valence, terminating my pregnancy is also low valence, and my pregnancy is valued by the pastor. By looking at single examples, we can infer different actors' intentions and quantities that they want to minimize and maximize. At the corpus level, we can infer the inter-actor diversity if we take this in mass and look at the norms and summaries across different agents. Okay, so that was very quick. In summary, we can take this text, these claims here, and parse it with our claim-based model. We believe that our SPEAR model permits more expressivity than other neural information extraction approaches, especially for knowledge-dense data sets. Our results in the ethnography domain show that SPEAR's knowledge graphs support practical qualitative causal reasoning, such as graph propagation and valence tracing. And I invite you to email me to learn more about our approach. And I'll be in the breakout session as well as in Slack. So thank you very much.
Thank you, Scott. There is a question on Slack for you. I don't know if you have access to Slack.
I'll have to unshare for that. Let's see. Yeah, okay. Are there any argument constraints on things like Q minus? No, there's not. That's a great question, actually. So I have a slide about that. I promise I didn't tell Matt to ask that. Yeah, so here we go. How do I get that? Oh, crap. Let me share my screen again. Okay, so language doesn't always deliver in this case. So if we say, differences in COVID-19 disease prevalence and severity are associated with sex and smoking is related to higher expression of ACE2. So right here with smoking and ACE2, is smoking the likelihood or occurrence or frequency, or is it the amount of smoking? We simply don't know from the text. Likewise, is this the occurrence of expression of ACE2 or the likelihood that it'll happen, or the amount of ACE2 that's expressed? We don't really know. Therefore, what does this Q plus actually mean? We don't know if we're talking about qualitative proportionality from an event to a quantity, from a quantity to an event, from a likelihood to a likelihood. It's kind of nebulous, unfortunately. So the text doesn't give us a foothold into that, and therefore neither, we don't even know the semantics of the Q plus, except with some assumptions we have to make on the outside. So if we assume that the Q plus, if we assume that smoking rather is a likelihood, and that this is a likelihood, then we could potentially use like Michael Wellman's qualitative probabilistic networks to look at the semantics of what this means. Otherwise, if we think this is an amount, and this is an amount, then we could talk about qualitative proportionality like QP theory, for example. But right, it's very ambiguous, unfortunately. So with our graph propagation, this is still plausible. But if we want to go any deeper with model-based reasoning, like Matt has done before in some DARPA programs, that's going to be a lot harder.